conservation of momentum. Three blocks are on a horizontal frictionless surface, and block M1 is 4 kilograms that moves at a velocity of 2.5 meter per second to the right. And a block of mass 52 kilograms moves over on the left with 2.8 meter per second. The two blocks collide and bounce off of each other, and the block M2 moves over on the right with 2.1 meter per second. And M2 then collides with M3 of 2 kilogram mass, and which was initially at rest, and the two blocks stick together. So the velocity of M1 after its collision with M2 with both magnitude and direction. So definitely, like I said, so there is no external force, so the momentum is being conserved. If the momentum is being conserved, then the initial situation is like this. So this is the block M1, which is of 4 kilograms, that is moving over on the right with 2.5 meter per second, and the block M2, this is 5 kilogram, which is moving over on the left with 2.8 meter per second. After the collision, the block M1, where is that moving, we do not know, so let's consider it as uh, V of perhaps let's call it V of A, and the other block is already moving on the right with 2.1 meter per second, and this is 5 kilograms. Okay, so the initial momentum is going to be 4 times 2.5 minus 2.8 times 5. Why minus? Because this is over on the other side, and that's why the momentum is negative. So this comes out as 4 times 2.5 minus 2.8 times 5, which is coming as negative 4. And the final momentum is going to be 4 times VA plus 5 times 2.1. So this is coming as 10.5 plus 4 times VA. So 10.5 plus 4 times V sub A is equal to minus 4, because the momentum is conserved. Subtracting both sides by 10.5, so we have this value added to 10.5, which is negative, subtracting 10.5 both sides, so that's negative 14.5, and dividing both sides by 4, we have the value of V sub A as 3.625 meter per second with a negative sign. So definitely the mass M1 is moving with 3.625 meter per second over on the left after the collision. Okay, so what is the change in the kinetic energy of block M1 plus M2 just before and after the collisions? That's also easier to find because that's just a matter of calculation. So the initial kinetic energy of the system is half times 4 times 2.5 square, because the kinetic energy is half mv square, plus the kinetic energy of this one, so that's half times 5 times 2.8 square, which is coming as 2.5 squared times 2 plus 2.5 times 2.8 square. I'm just doing with calculator. So that is coming as 32.1 meter, joules. Final kinetic energy is going to be half times 4 times VA. What is VA? 3.625. 25 whole square plus half times 5 times 2.1 square. So that's going to be come out as 3.625 square times 2 plus 2.5 times 2.1 square. So this is coming as 37.31 joules. 37.31 joules. So that's how the that's how the kinetic energy of the final combination is going to look like. All right, so if that is the case, then what is the change in the kinetic energy? The change in the kinetic energy is going to be 37.31 minus 32.1 1 from here. So if we subtract, then this is coming as 5.21 joules. That is the change in the kinetic energy, right? Then let's talk about the next part. All right, okay. Then we have to find the velocity of m3 after its collision, then the change of kinetic energy of m2 plus m3. So remember that m2 and m3 sticks together. So the momentum is conserved. Initial momentum of m2 m3 system is only because of m2. So that's going to be mass of m2, which is 5, times the velocity of m2, which is 2.1, and that should be equal to the final momentum. And final momentum is 5 kilogram plus m3 is 2 kilograms, so that's going to be 7 kilograms since they stick together, times v of, let's call it c. So 7 vc should be equal to 5 times 2.1. So the value of vc from here comes out as 2.1 times 5 over 7, which is 1.5 meter per second. That is the value of v, the velocity of the block C, over on the right, of course. Then we talk about the change in the kinetic energy. So once again, the initial kinetic energy is only because of the block 5 kg. So that's half times 5 times 2.1 square. And the final kinetic energy is because of both. So that's half times total mass is 7 because they join together, times 1.5 whole square. So let me just grab my calculator. That's the first one is coming as 11.025 joules, and 7 over 2 times 1.5 square is coming as 7.875 joules. So definitely the change in the kinetic energy is the final minus initial. So this value is coming as negative 3.15 joules. This is the change in the kinetic energy. And these are answers to all the four parts.